Today we're going to be looking at learning target 8B, which is exponential functions. The first thing we're going to look at for exponential functions is the general equation. For the general equation, we have two pieces that will change depending upon the function. The A value stands for the initial value. When we looked at geometric sequences, that was labeled A sub 1. So I'll put that up here. And the B value is the common ratio. That's what we are multiplying by each time in order to make the exponential function. And when we talked about with geometric sequences, we used the variable r to represent that. So the A and the B value act very much the same way as the A sub 1 and the r value for the geometric sequences we looked at in learning target 8A. Now that we understand what those two pieces mean, here we're going to look at the function y equals 2 times 3 to the x. Now in terms of graphing it, I always recommend using your graphing calculator. So here I'm going to go to my y equals, and I'm going to plug in 2 times 3 to the power of x. Now I could put that 3 in parentheses if I want, but in this case I'm not needing to do that. Now I'm going to go ahead and look at the graph just so I get an idea as to what this graph will look like. So notice it climbs really quick. But I'm going to go ahead and use the table of values to help me plot these points. Now notice everything in the negatives is super small. Our first real value that I'm going to plot is at 0, 2. Now notice this table is going by 2's in every direction. I've got 1, 6, so I'll plot that point. 2, 18, which is up here. So my graph is going to look something like this. And will continue forever in both directions. It's important to note that all my negative x values, if I were to keep scrolling up here, notice they keep getting smaller and smaller, but they'll never actually get to 0. So when you draw this graph, make sure that the tail end of it over here stays above the x-axis. Okay. Let's go ahead and look at another example for graphing. We've got y equals 4 times 1/2 to the x power. So again, I'm going to get onto my calculator. This time, because I'm dealing with a fraction, I am definitely going to be using the parentheses. So I'll do 1 divided by 2 in parentheses to represent that 1/2 to the x power. I'm again going to look at my table and notice how this time all my negatives are super high numbers. You see that? And then everything that's positive keeps getting smaller and smaller. So this is an example of an exponential decay. So I'm going to go ahead and plot some of these points. So I've got 0, 4, got 1, 2, I've got 3, 1/2, 2, 1, 3, 1/2. So it keeps getting smaller and smaller. With my negatives, I've got negative 1, 8, and negative 2, 16. So you can see that this graph is going downward. And again, just like the previous graph, everything over here keeps getting closer and closer to 0. But if I keep scrolling down more and more positive, it never actually gets to 0. It just keeps getting smaller and smaller. So when it comes to exponential growth and decay, if the B value, the number that's being multiplied, that common ratio, if that B value is greater than 1, the graph will increase, and it will look something like this. If the B value is less than 1, the graph will be a decrease, and it will look something like this. The only other case that we look at is if B is equal to 1, then that means that your graph will be constant. It will just be a straight line from left to right. I want you to take the time now to do some practice problems. For the first three, I just want you to identify the A value. So where is the starting value? Where will the graph cross the y-axis? And also identify the B value. What is the common ratio? What are you multiplying by each time? And for the bottom two, go ahead and create those two graphs. Go ahead and pause the video until you've had a chance to do this. And here are the solutions for those practice problems. Notice that the initial value, that A value, is always what starts. The B value is always raised to the power of x. And with the two graphs down below, those are both exponential growths because that B value is greater than 1. We will be doing some practice with this over the next couple days. So if you have any questions, please make sure you ask Mr. Dunn, Ms. Knutson, or myself.